So this will primarily affect ISE and Pmax. It will transmit also on Pmax. It will be almost 1.7% for Pmax as well. Now, we have also done a more, let's say, statistical investigation. So generally, for modules in production that they have small differences in the encapsulation packets, it is possible that we have spectral mismatch, which can be as much as 2%. Employing a solar simulator that has a better spectrum may help a bit, but is not so significant. The key point here is to choose a reference spectrum that is, a reference device that is spectrally matched with a module in production. That means they have exactly the same bill of materials, like I said before. This will enable to reduce the spectral mismatch uncertainty to less than 0.5%, or actually even less, regardless the class of the solar simulator. And now I would like to move to the next one, which is the non-uniformity of irradiance. Non-uniformity of irradiance may cause many funny artifacts in measurement, and one of them is related with how you position the PV modules. Here, what I'm showing you is we have taken a reference module and we have measured it, and then we turned it 180 degrees around and repeated the measurement. So you see that in the first case, the ISE was underestimated by 0.7% comparing to the true value, and in the second case, ISE is overestimated by 0.5%. Although there is a much smaller effect on Pmax. However, if the manufacturer is using ISE as a reference point to calibrate the simulator reference irradiance, then the error that you see on ISE will also transmit on Pmax. Electrical circuitry of the PV module. So here I'm sharing excuse me, two examples. In the first, on the one on the left, we have a test plane that has more light, receiving more light on the right-hand side than on the left. And on the right example that I have on the right-hand side example, we have a non-uniformity pattern that has more light on top than the bottom. So the red area has more light, let's say. On the example that I have on the left-hand side, all strings of the PV module will receive the same current. So the current that goes through each string will be evenly distributed. This will cause an underestimation of ISE and also an underestimation of Pmax. But the effect on Pmax is much less pronounced than ISE. On the right-hand side example, because we have an uneven current flow within the strings of the PV module, the bypass diode will kick in, and we'll have this typical step of the bypass diode, which